Nearly everything will change. We have on one side the voltage level, which will change from 12 to 48 volt. We have the electrical architecture, which will completely change. And the known big wire harness system will be cut in future into several smaller sections. And what does it at the end mean? So since several years, we see that today's a lot of small function-specific electronic will be grouped into larger units. This has an advantage, it saves cost, and on the other side it allows OTA compatibility. OTA means over-the-air updates. These systems called domain architecture. And already today we see the next iteration phase of these systems. These systems have only a handful of very powerful, very big electronics in a car. And this system called a zone architecture consists typically out of an HPC, one brain, a high-performance computer, and on the other side, zonal controllers. These zonal controllers, typically 2 to 3 per car, are important components because all loads, all sensors, all actuators are directly connected to these zone controllers. That improves the wire length, it becomes significantly smaller. That allows to reduce the total weight of the system, and these smaller sections give the chance for future improved automated manufacturing content. How this could be done? The smaller wire harness sections typically come with a smaller amount of variance. This allows machines to handle it. And this is a core technology from SEBN, Sumitomo. We are using standard equipment on the market and our own designed equipment to ensure that now nearly the whole process, beside cutting, crimping, taping, also the full automated manufacturing and feeding of connectors is possible. I mentioned in the very beginning an additional important topic, that's the voltage level. It sounds a little bit strange, but the step from 12 to 48 volt is a relevant point. Because if you see, if we increase the voltage, at the same time we can significantly decrease the current. The reduction of current means we can use smaller wires, smaller connector systems, we have more free space, and we reduce the weight. Especially weight is an important topic because for such a wire harness we could save 6 to 7 kilogram in copper weight, only because of this. And as mentioned, the smaller connectors allows the use of modular connector systems. And the Sumitomo modular connector system is an important detail, ensuring that this technology can be applied. And here my colleague Alex can share with us, I think, much more interesting details.
Thank you, Karsten, because the modular connectors, they are providing very simple but very powerful concept for the modern industry of the wire harness. They're combining a lot of different signals, like signal power, in only one simple housing instead of using multiple single connections. And this is very essential for our harness development, especially within our organization, because we can simplify our harness system. So, and as Karsten mentioned, the key advantages of using of the model connector, especially for the zonal architecture, for sure, saving a lot of space and weight within a compact assembling. Secondary, they providing us a possibility to reduce and simplify the variance of the harness. Third, the assembling process will be much easier, just inserting the standard housing and maintenance. And last but not least, the maintenance will be much easier because instead of rewiring of the whole wiring system, we just need to disconnect or connect our new models. This is exactly the point, because within our organization, we can achieve very great synergy effects, integrated the model connectors or development of the model connectors in the wire harness already in the pre-development phase.
As Alec just described, we rely on copper terminals and connectors for the electrical data transmission, a tried and tested, well-known and reliable connection technology. They are getting faster with improved shielding and better materials, enabling multi-gigabit speeds over just a single twisted pair. But let's be honest, they are reaching their limits due to EMI and signal loss. So enter Sumitomo Electric's optical data connector technology, lightning fast, immune to interference, and ready to handle tomorrow's data stream. The catch? Well, they have to become better to survive the harsh automotive environment. Like vibration, temperature swings, and dust aren't exactly their favorite environment. So the future, we recommend a hybrid mix. Copper weight makes sense, optics where speed is king. Because in the race for automotive data, it's not just about speed, but surviving the ride. Another important topic is digitalization. As Karsten just pointed out, vehicles become more complex and increasing electronics components and data demands. Therefore, the traditional manual wire harness design process is just not longer sustainable. So here, digital tools are revolutionizing this process, enabling virtual prototyping, automated wire harness routing, and real-time collaboration across engineering teams. With advanced software and 3D modeling, we can simulate wire harness layouts early, identify potential issues, optimize weight and space, and saving time and reducing costly physical iterations. Integration with vehicle architecture and linear systems ensures a better accuracy and traceability throughout the development cycle. Moreover, digital twins and AI-driven design recommendations are starting to play an important role, helping us to predict performance and to optimize manufacturability before a single wire is cut. In short, digitalization is transforming the wire harness design process from a labor-intensive craft into a streamlined, data-driven engineering discipline, paving the way for lighter, smarter, and more reliable automotive ENS systems. Finally, I want to touch a topic which is no longer optional: sustainability in wire harness design. So as the automotive industry drives towards electrification and smarter vehicles, our harnesses can't be just efficient. They need to be green. This means rethinking materials, moving away from traditional plastics and heavy metals due to bio-based, recyclable, or lighter alternatives that reduces the environmental impact without compromising the technical performance. It also means rethinking wire harness design to be easier to disassemble and to recycle at the end of life, supporting here a true circular economy. On top of that, optimizing wire harness length and complexity not only cuts weight, improving the vehicle performance, but also helps to reduce material waste and to reduce manufacturing energy consumption. So as mentioned earlier here, digital tools help us to simulate and to refine the wire harness layouts before production, minimizing trial and error waste. So in short, Sumitomo Electric's green wire harness design is about integration of our engineering excellence with environmental responsibility. So in my opinion, an essential consideration as we develop the wire harnesses of the future.